Hey, hi Shantanu. Good morning.
Hey Vijay, good morning.
Yeah. So I guess out of the five folks that are there in this program,
Yeah.
two have joined, and if you want, we can wait for a couple of minutes, or if you want, two folks have already joined, so we can start.
Okay, I think we'll wait for about 2-3 more minutes and we can
Yeah,
begin.
yeah.
Yeah.
Sounds good. Good.
Awesome. Morning, Pooja.
Hey Purva, thanks for joining.
Yeah, thank you. Good morning to all of you.
Good morning. Hey Dave, thanks for joining. Guys, we'll start in a couple of minutes. So Shantanu, I guess barring one, everyone is joined. So,
Awesome, cool. I think we can.
so you can start when you want. Cool?
Okay, great. Uh, so thanks a lot again for everyone joining in, and thanks Vijay for organizing this.
Yeah,
Of
thanks.
course, for everyone that's joined, it would be super helpful if you guys can bring up your cameras. I know it's 8 in the morning; it's probably uh, tough, but for those who can, I think it'd be super helpful. I'll give you guys about 30 seconds to. Yeah. Thanks, Dave. Hey, Purva. Thank you. Hey, Abhishek. Thanks, Vijay.
Yeah.
Awesome. So, cool. I think I'll begin. 1 second. Let me just share my screen with you guys.
Uh, yeah, we can see your screen now.
Awesome. Just give me a sec. Yep. Thank you guys. So again, I think today's session is primarily about walking you through, say, an end-to-end life cycle of what we do in an entire, say, a day, or maybe even just walking you through what a day looks like and how we plan our quarters and so on and so forth, extending that to, uh, say, a longer tenure to just tell you how it is to actually be back in the field and trying to accomplish certain tasks on a daily basis for the business. So a couple of things that I wanted to initially touch up on, of course, right? And you guys are enrolled in the program, so you're aware of what a data scientist is, but wanted to make a distinction, of course, which is the fact that a lot of times the word data scientist, which is used for very analytical individuals, and not someone that is hardcore, say, into engineering and software and also analytics. So, two broad distinctions, and I wanted to make them early on. After which, I wanted to hear from you guys, uh, if there's anything else that you guys have heard about this, and then moving forward from there. So, the two broad distinctions that are made is a data scientist, and people call it a unicorn data scientist of sorts sometimes. And a unicorn data scientist is basically someone who, uh, say, and we at LinkedIn started the entire data science, uh, say, terminology of sorts, and it's basically someone who owns the entire end-to-end pipeline, right? And by pipeline, I mean starting from gathering your data to making sure the right data is in the right place, gathering your metrics correctly, analyzing that raw data to bring it to businesses, making models if you have to, and then presenting to business to make actionable insights. That is the entire life cycle of sorts that we've been following as data scientists. But a lot of times people call this the unicorn way of going about it, because I'm sorry, I think my screen share just stopped. Yeah. So people call this unicorn differently because a lot of times a data scientist is not supposed to bring in all of your data in many organizations, and sometimes you're not supposed to create all the models. Maybe the machine learning engineers are supposed to create models, and so on and so forth. So when I say data scientist right now, I refer to a data scientist that will cover even the software engineering side of things, and not all of it, but say some parts of data engineering, lead that into analytics, and then lead that into, say, business decision making. Also, want to hear from you guys if you've felt there are any multiple explanations that you might have come across before this as well. Awesome. So I'm assuming everyone's aligned with this one.
So guys, feel free to ask questions. That we make the session more interactive. That'd be great. Yeah.
Yeah. Also, in fact, I think just wanted to hear from you guys beforehand. How many of you are you guys all in the data science industry? Are you guys studying? Are you guys already working? Just thought I'll get to hear from you guys real quick.
Yeah. Hi, Shantanu. It's Abhishek here.
Yeah, Abhishek.
Hi. So I'm working with one of the oil and gas sector company. So I'm having 11 years of experience, and I recently saw some use of data science in one of my department.
Yeah.
So although I don't have very much idea, but yeah, I heard little bit about it, and
Oh,
it
that's
is
great.
still using in my company.
All right. Thanks a lot, Abhishek. Anyone else wants to go? I'll just take one
Yeah,
more. Hey, Purva. Yeah.
I'm working as a business analyst in a fintech. So there are a couple of cases which will be coming up in our product itself, which will be in which we want to use data science. So I want to lead that as a business analyst, maybe, or as a data scientist.
Yeah. I think very interesting that you mentioned business analytics, because that is also one arm of
Uh,
a lot of,
no,
yeah,
I'm currently working as business analyst, more into like project management and
yeah,
releases. But I have coding background previously,
yeah.
so I'm looking forward like I can get the new role.
Right, makes sense. And I think fintech as well as oil and gas, I think these two industries, fintech, of course, has incredible potential in data science moving forward as well, because that is a lot of what happens in finance, in even the stock markets, in economics, which is a side role to, say, finance. And all of these industries, I think, have incredible potential. Oil and gas, I personally know that has a lot of potential because it's moving from, say, the larger data tracking is a problem right now with oil and gas, but I think a lot of these industries have definitely incredible scope moving forward. So what I do is I'm a data scientist with the growth flagship product at LinkedIn, and just dividing what we have. So LinkedIn has about I think the background that you see is just something that we'd all put up recently because LinkedIn celebrated its 17th birthday a couple of weeks ago. So I think this was last week, and LinkedIn was founded in 2003 by Reid Hoffman, who was also, they're known as the PayPal Mafia, basically, which is Elon Musk, Reid Hoffman, and all of these people that first founded PayPal and then went on to found other very large scale companies. Elon Musk made SpaceX and Tesla, and a lot of other founders made YouTube. Reid Hoffman made LinkedIn. So I think this LinkedIn was, of course, what I do is born out of the passion that I've had because I've worked at Udacity before this, and at a startup that just went to Y Combinator recently as well. So I think particularly LinkedIn is primarily about, and I'm sure all of you have used it or at least heard about it enough, is connecting the right people to opportunity is something that we do. And of course, at scale, LinkedIn has about, in the data science team, the data org at LinkedIn is very, very powerful in that uh, I'm not sure if you guys have heard of DJ Patil, who was the chief data scientist of the United States. He was one of the early employees at LinkedIn Data Science, and he's the one that has set a lot of tone of data science in the industry. And the word data scientist of sorts was coined first at LinkedIn in about 2008 between Jeff Hammerback and uh, DJ Patil. So I think it comes from a long history of LinkedIn, particularly being extremely data driven, in that some companies, and I'll give you just an example, right? A/B tests and all of these things that are something that we commonly run. And LinkedIn runs over thousands and thousands of them on any given day, which means there are so many variants of LinkedIn running as we speak. And you may just be experiencing two different LinkedIns as two different people. We have in our flagship organization, so we call in LinkedIn AI or LinkedIn Data Science, we separate LinkedIn Data Science into trust data science, which is to make sure that content quality remains top notch. And we have, say, machine learning models or classifiers or even analytics to help us trying to figure out what particular, say, content is coming out bad so that we can spot it, remove it from LinkedIn, so on and so forth. A lot of spam, a lot of low quality content, or sometimes even abusive content. Uh, the second data org is, I believe, BizOps, which is business related, which market to enter first, what to do next. The third one is marketing data science. Marketing is, again, working very closely with the marketing team, so on and so forth. There's one more which I'm forgetting. And the fifth one, which is what I'm a part of, is called the growth or the flagship data science, which is basically working on the core product that LinkedIn has that users get to experience, right? The mobile app, the web app, the actual LinkedIn product, which is, say, building LinkedIn groups, building the LinkedIn job portal or something like that. So the actual core product is what we do at Flagship DS. We also call it growth because it is forward looking in that we're looking to grow more in the same direction that we're in. And this remains something that a lot of organizations will split into their teams. Like one of them remains the main team that works on the product. The other teams are supporting teams that support the ancillary product of sorts. So a couple of business problems that I do solve on a daily basis at LinkedIn. And currently I'm aligned to the groups product on LinkedIn, which is LinkedIn Groups. But of course, wanted to hear from you guys as well once I cover this part is, say, the things I do right now for LinkedIn are being aligned to the groups product. One of the key business problems that has come to us is that they're hard to find, right? LinkedIn groups. And for those of you who are here today, if you even think about what Facebook groups you are on, for example, I think you have a fair idea on what kind of groups you are on, what you do in those groups, so on and so forth. But if I ask you if you are on any particular LinkedIn groups, it doesn't come to mind as something that will have very high recall value, because we probably don't know, even if we're part of LinkedIn groups, even if we know we're part of LinkedIn groups, we're probably not as active on them a lot of times because it's not relevant to us most times, or it's just too large for us to be able to contribute something actively. I think these are two big problems that we're trying to solve. Activity of LinkedIn groups is again something that we're trying to solve for, which if you guys even notice on Facebook is a big problem, because sometimes people don't actively contribute to groups as much as they actively contribute to their feed, and which is normal. But if it gets below a certain threshold, then it becomes a problem of sorts, and we're trying to solve that using data science. The third one is the most exciting but also the most excruciating part for us right now, and particularly for me, because we're trying to define what we mean by a healthy group, right? So if you think about some groups that you really enjoy being a part of, you will find that there are very few of those that you actually enjoy contributing to, giving back to. And to define the set of groups that are actually performing over time is something that we're trying to find through a definition that will say, this group is healthy, this group is not, and this is how to do things. So these are three broad problems that I'm solving in my day-to-day work. I just wanted to understand from you guys as well, if you have used your own products, and a lot of times some industries may not be able to use their own products, but does anyone want to share what kind of business problems you guys might be, if not solving, at least experiencing around you? Something with, say, fintech could be something like trying to predict maybe the stock market, or trying to do something of that sort, or just getting out better content. So is there any business problems that you guys are looking at?
Yeah, I can speak a little about that. My
Yeah.
company is into supply chain finance,
Yeah.
and what we are trying to solve with data means data analysis or data science is basically what kind of behavior supplier has after taking a loan. So if he repays on a time, or he overdues multiple times, or he pays before time, before the due date appears, so that kind of behavior is means that is the first thing we want to target. So it will increase the credibility of that supplier, that he can repay the loan or not. And other than that, we are targeting on what sectors SCMs use most. So from the supplier, we can get that information, and we can plot that, like what different domains are coming up for the supply chain finance.
Yeah.
So that are like two business problems we are targeting right now.
I think that's great that you bring up these problems, because a lot of times one of the biggest disconnects that exists in a data science field is that what is my business problem versus what is my data science problem, and there is nothing really called as a data science problem as much as they're all business problems. So I think that it's great that you bring that up. Anybody else wants to share a couple of business problems from their domain? Awesome. So I think I'll have to start calling out individuals. Just give me a second. Yeah, I think Dhruv and Anurag, you guys just recently uh, joined as well. So do you guys want to share what industry you're in, what kind of problems you may be looking at?
Yeah, so I can go ahead.
Awesome. Yeah.
I firstly, so I'm working in a management consulting startup, and the sort of problems we look at are like we help our clients with commercial due diligences and even strategy projects when they want us to say validate market space before if they want to enter it or not, or when they are expanding into say tier 2 or tier 3 cities.
Yeah.
So like their go-to market strategy. And so these are sort of like two main projects that our firm gets. And yeah, I mean, we
Awesome. Which startup were you in? I think, did you mention that? Or
no, so the name of the company I'm working at is called Praxis Global Alliance.
yeah, yeah.
Have you
Awesome.
heard
I
of
think
it?
that's yeah, I have.
Oh,
Interesting
nice.
because surprisingly, when you did mention management consulting and a startup, I think there are very few people in the management consulting space that will not go to say the big three, and
Yeah.
a lot of people are doing great work outside of the big three as well. So I think that's
Hmm.
a very cool reference that you make, particularly for management consulting. I think it's a great way to get into data science because you guys have a very abstract set of businesses that you work with, and
Yeah.
you may be switching domains too much. So I think it's a great thing that you align with the class as well, because I think your perspective on business problems will be interesting to hear because they'll actually be business problems from management, leadership, and everything.
Hmm.
Awesome. So across the board, I think when you guys embed yourselves in the data science industry, I think one of the uh, core things that you will think about eventually is where is most of your time going, right? Because this becomes sometimes too complex because you're just in caught up in exploratory analysis and it's going nowhere. It sometimes just goes in circles a lot of times. So my typical workday, of course, goes entirely in exploratory analyses and sometimes just setting up, say, depends on what um, phase of the quarter I am in. Because in the start of the quarter, my day is probably going into planning, into setting up certain dashboards, or maybe even some data pipelines that I will eventually start to use as I progress in the quarter. But my actual quarter looks a lot like EDA, where I'm just exploring, say, multiple cuts of a data that I'm supposed to explore to find trends to reveal, say, a trend or a behavior going forward. And just an example of that is recently, I think, since I'm working on the groups product, one of the things that we've realized at LinkedIn is a lot of our group recommendations are for very large scale groups, say groups that have 10,000, 20,000 members. And we're just trying to understand if those groups have a better click through rate, which means if I recommend a small group to you versus if I recommend a large group to you, which one are you more likely to join basis your recommendations? And once I figure this out as a business, I now know which one to prioritize to new users, to old users, to say a particular user, which kind of group is mapping the most so that they make maximum contributions. So these are some problems that we explore a lot on. Most time goes particularly in EDA because it's sometimes very, very challenging to keep going around circles trying to figure out what to put where. It is easy with abstract. I mean, it's easy with direct problems that, click through rate, which group is getting more, which group is getting less, so on and so forth. But when it gets a little more open ended, right? Like, say, how do I define what a healthy group is for me? Or taking a reference from, say, some, say like an education industry, maybe if I'm in a classroom and if I want to figure out what is called a good learning outcome for a student, sometimes it gets very, very abstract to identify, or a very open-ended one with the stock markets as well, right? Like, where is this probably stock going to be 10 years down the line, or what do you call a good performing stock? Now, a lot of answers to what you call a good performing stock, but is that the answer that you want to go with? Do you want to explore a new answer? So that just spins up a new narrative, that just spins up a new domain of exploratory analysis that sometimes has you going back to the entire start, where you have to think about, what is this stock, or what was this group created for? And once you find that out, then you come to this must be the learning outcome for the group and how many are then achieving it, and so on and so forth. And so again, most part goes in EDA. The other sizable proportion of sorts goes primarily in supporting, say, data infrastructures across the board. And this must be like experimentation, and experimentation is something that takes up a huge amount of our times, because as I said, there are about thousands, I can't get to a number of sorts, but thousands and thousands of variants of the LinkedIn platform running as we speak. And LinkedIn prides itself to be one of the most experimentative companies out there, in that we experiment everything, like the color of a button to a new website to whatever, a backend algorithm changing. We experiment almost every single thing. And that takes us to about 3 to 4, 5,000, maybe even 10,000 experiments in a quarter. And that is an unimaginable amount of scale of experimentation that we're running at. And personally, before I came here, I think experimentation was something that we didn't experience at this scale before. And again, supporting data infrastructure was one. Deploying and designing test experiments. Product meetings is something that I wanted to elaborate on as well a little. That sometimes when you collect data, when you're supposed to present it to product or even guide product strategy in something, right? So if I say that there are more topic-based groups on LinkedIn, if you guys can take like 10 seconds to think about what kind of groups that you might be using on Facebook, you'll find there are topic-based groups, there are some absolutely random groups, and there are some funny picture groups, and so on and so forth, right? So if the product thinks that topic user communities are something that need to be built more on the LinkedIn platform, how do you support that with the relevant data and so on? So a couple of stakeholders and teams that I work across, and I think you guys will find yourself working in these spaces, in these fields as well, right? So I think what we need to understand at the base is that data science is something that's it's like a value add function at the bottom of each function, right? So you can also support marketing, you can also support engineering, you can sometimes also support, say, of course, you can most definitely support product. You can also support, say, design, and a lot of people discount that design can be supported in some way. But I think these are just some stakeholders I work with across the team. But of course, this is testimony to the fact that LinkedIn works in a different way, in that when we have a groups team, our groups team usually consists of one lead product. Then there's one lead engineering, one lead data science, one lead design, and so on and so forth, right? So when six, seven of us come together, we have our teams behind as well, sometimes not helping, sometimes helping, but that usually generally makes for a very closed knit team of sorts. I think that's just the way we're looking to work. A very interesting case study that I think we did with LinkedIn as well, and a lot of design companies do this. I'm not sure if any one of you have worked with, say, the Adobe tools, the Adobe Photoshop, and so on. So I think one of the key things that you'll find at the bottom, right, Adobe wanted to create, and just as an example, LinkedIn also wanted to create a mobile app version, right? Initially, LinkedIn was only web at one point back in the 2008-9 era, maybe. When they had to make the move to app, one of the core things you have to think about is what kind of user behavior you're seeing on the web. And just as an example, if you guys are all in organizations that are probably web apps, or not even web apps, sometimes trying to move to web apps, some are trying to move to app. The thing that you need to understand is how are your end users behaving with your web, right? So at LinkedIn, we wanted to figure out, in that small app, you can only put like 3-4 buttons on the top starting. What buttons do you choose? Do you choose buttons that are used most commonly? If yes, do you also choose for pairs that can keep adapting as you click a button? Say, for example, I click my connections button, and maybe I want to see, and I'll just show it to you guys, in fact. Just a sec. So as you see here, right, I think you'll find there is my network, jobs, messaging, notifications, so on and so forth. And now what happens is when I say want to click a particular button, start a post, these are 6 things that come on my web app. But which 2 ones that I can use first is what I will usually put in, say, a mobile app. Because I know for sure, sometimes I know for a fact that I can't fit all of these buttons on my LinkedIn app anyway. So maybe I see that celebrate a teammate and share that you're hiring are 2 buttons that are used very, very widely on the LinkedIn app, on the LinkedIn web. So I take only these 2 buttons, and then the third button is probably like an other that has all the other remaining options for you. And I think that is one of the crux of how we do certain web to app transitions, or even some transitions that you might be doing on very common platforms. And that is where the integration of design sometimes is very, very crucial. So of course, wanted to take some questions from you guys before I jump onto this. If there's anything that you guys wanted to run by or ask before I move forward. Awesome. So how does, say, a data scientist now, right, or how do I particularly build my own capabilities, my own team, and support my own team, and you learn a lot of technologies every day? So surprisingly at LinkedIn, I think this is a culture that's very supportive of employee growth and learning. And even organizations, like it's called the 20% rule, I believe, a lot of organizations have now started to use the 20% rule, where I know for one, Staples does it very well. I know that Atlassian does it. Atlassian is the product that creates the Jira boards. Uh, so I know these 2 organizations. Google does it at immense scale, where they give 20% of the employee's time back to the employee so that they can, build on themselves, build their peers, make meaningful connections. I think these are a couple of things that help with the 20% rule. Just as a trivia, I think you guys should read up about Google News and a lot of incredible products that came out of employees brainstorming in that 20% time. I think that's very beneficial to the business as well. I think that's one way that I particularly build my own capabilities. A lot of times we spend time on LinkedIn learning quite some bit, but sometimes I think one of the best ways to also learn just becomes, throwing yourself of sorts in the work that you're wanting to learn or supposed to do. And I think some good learning and some great learning sometimes comes out of that as well. On the other hand, if you're someone that's getting into the field a lot fresher of sorts, like maybe it's your second job or your third job, maybe it's the first one that you're picking up in the data science domain, one of the key things that you could think about is a lot of experiential learning will help you and take you a long way. And by experiential learning, I don't just mean projects or code, but I also mean something like attending some meetups or attending live hackathons, because those are some, and I'm not sure how many meetups or live hackathons are going to happen in the year to come right now, but I think it's a great way of sorts to just get yourself embedded into the ecosystem. It really helps you learn from peers and people around you in a great way, so that you can make sure that you're doing a lot in terms of building your own capabilities, building and keep moving forward in the same field that you're in. And particularly if you guys have any instances of how you've learned early on, I'd love to hear that. I think I've heard from a lot of people except a couple. So maybe Dave, if you want to share something about how you've picked up in this field, how you've started, where you are right now.
Yeah, Shantanu. So basically, I have 9+ years of experience in application support in IT. So basically, I'm currently I am just upgrading my skills in this particular domain. Okay. I haven't just started to work on the data science part.
Yep.
So I'm totally new to this.
Awesome. And how do you mostly spend your time learning in this field? Do you use the program? Do you use blogs? What kind of learning material are you usually?
Yeah, so currently, I mean, I'm using the Creator platform. Plus, I'm also reading some of the articles that are published on Medium.
Yeah.
And also, I mean, I try to solve a couple of problems that are there in the Kaggle. So I'm just started. And also, there are a lot of coding platform, right? So I try to solve the problems that are posted there, some easy problems basically, because I don't have much of hands-on in technologies on daily basis. So
Yeah.
I'm trying to solve problems on through Python.
That's great to hear. And I think one of the very important things that you mentioned is Kaggle, right? Because a lot of people sometimes discount what Kaggle can do for you. I would recommend everyone who has, and I think the prerequisite of sorts is that I hope you have a great and stronger understanding of the language or the code that you're using. You don't have to have a great understanding of it, but at least I hope you're hands-on with it yet. And if you are, I think Kaggle is a great place to help you just get into the business of sorts, because you'll see a lot of business problems out there. You'll see people solving problems from one end to the other, like from business problem to actual data science solution. And I think that's a great platform for all of you to learn. When I personally started off in the field, I was a lot younger. So I started off about 6-7 years ago myself. And I think a great benefit of sorts was that my dad did AI for the Indian Navy in some shape or form. Had a lot of books at home, particularly. So just started up picking up reading some of those. Read them once and just probably left them and never touched them again. But came back to them eventually, saw there was some merit in them, tried reading a lot of books, going through a lot of talks online, attending meetups. Hackathons, I feel, are the single-handed amazing way to build your capabilities, because you get real-time feedback, you can present your solutions, and so on and so forth. So hackathons, I think I'm an absolute fan of how those are conducted. The other route, of course, is taking Kaggle, which is also a great way as well. But as you get inside the field, if you're working, I think books and talks and meetups remain a couple of 3 things that you should definitely do. Meetups, I highly advise meetups, because you'll get to meet like-minded people and you hear something, or somewhere you just hear some stuff. And I think that helps you grow in the field you're in a lot. And I think this very famous quote as well. I'm not sure who quoted it, but you are the average of the 5 people you most interact with, which means if you surround yourself with the right kind of people, your average will skew for the better for you. I think that always remains something that I follow, which is why I attend a lot of meetups and a lot of these conversations on a daily basis. I would recommend you guys read books from different domains as well. I'm not sure how many of you are into reading, but I would recommend you read books from a lot of different industries and a lot of different domains as well, so that you can apply, and it's more of like a polymath way of solving things, that you feel if you get knowledge in one particular domain, you can use that to solve problems in another domain. And it really helps sometimes, because I've been reading a lot of economics, and I read a lot of, say, behavioral psychology. And I think these genuinely help in your data science journey, because economics problems sometimes are very spread based on narratives and based on, say, they call them a idea web or a narrative web of sorts. And in data science and NLP, you'll find a similar application of a web going around with, text, data, just people talking about same things in different pockets. So I think it's great for you to read books across your domain as well. I'll share a link for a talk. I think you guys should check that out. It's Hans Rosling's talk. I'm not sure if you guys have come through it, but I always make sure to share this particular talk. Just give me a second. The best stats you've ever seen, it's called. Of course, I'm not going to play it, but I'll just share it with you guys on the chat right now. So of course, coming down to what as a data scientist you will find are some rewarding moments and some frustrating moments. I want to go over the frustrating first because it is genuinely frustrating, and a lot more frustrating than the rewarding is rewarding. But when data is mostly messy, right? I think one of the bigger problems with messy data is that you probably can't do the best with the kind of data you have right now, because it is, and I'll give you an example. If you're trying to find out the addresses of individuals, if you're trying to do a address level analysis for finding out how many people live in the same neighborhood, maybe some people don't enter their address correctly. Maybe some people, if you're doing an online e-commerce transaction, right, how many times will you just randomly put some things at the end of it? Because the first couple of things you have to put right, because otherwise your order won't come. But the other couple of things, sometimes people just bomb it and people just do a very bad thing of it. If I write my flat number, my colony name, and then I just put like New Delhi, right? So it gets very tough, because what if there are more colonies with the same name? So then you move on to pin code analyses and so on and so forth. But I think address analysis is something that data gets a lot messier in. Your interpretation gets harder of the data, your analysis gets harder, and it gives room to a lot of confounding variables. And confounding is basically you find a relation between two things, but it might not be a direct relation. There might be a third variable involved somewhere in the middle. And just as I was saying with addresses, right? Maybe you find flat number and maybe you find colony name, and you think that they are an indicator of something. But till the time you find that pin code, maybe there's a missing variable somewhere that is actually making the difference. So I think this is a very, very frustrating part. Also, exploration, right? When you're trying to explore, say, what a healthy group looks like, what a non-healthy group looks like, you're just spending so much time on figuring out whether this is the right definition to put here, this is the right way to go about it, so on and so forth. It just gets to becoming a never-ending cycle that sometimes you're just confused about how do I define something when I don't already know what it's supposed to be like. I think these are a couple of things that just really get to you sometimes. On the other hand, it is amazing to see your work being used to drive new product innovation, because a lot of times you'll find that, for LinkedIn groups, if there is a new group definition that we create, like we say that this is a healthy group, this is not a healthy group, then we use that data to make sure that we only now recommend healthy groups, which in turn gives me a lot more direct business impact, like helps users actually use the product better and a lot of things like that. So I think that's been a great reward of sorts that comes with being in the journey. And I think it's, as I mentioned, right, like you have to be very solid and sure about the handling the frustration, because more than just two of these things, one of the core problems that comes in this is that you're going in cycles, which means you have to have enough energy to be able to start the next cycle, because sometimes you're so exhausted that nothing has come out of this. You probably don't want to start again. Like you're just, 10 cycles into it. You're probably thinking, if 10 cycles didn't get me anything, what will the 11th cycle even get me? So that frustration is something that normally comes. And I think it's very useful to understand that that is something that you will have to be very adaptive to and accepting of, because it gets tiring.
Shantanu, I
Hey
have a
Purva, yeah.
question here. So, as you said, like exploration is a main part, but if I take an example, like your business problem is to determine the healthy groups. So, who gives you the definition of the healthy groups, or you have to derive that from your own experiences or your own mindset?
We have
So
to
it is
derive
given
that.
by
Yeah.
the business, or you have to use your brain or your mind for that, basically.
We have to use all of our mind for that. The business sometimes gives you absolutely nothing, right? And that's what sucks, because the business says just define, I want to know what groups are doing well. I want to know what groups are not doing well.
Okay.
And that's all the business gives you sometimes. So just as an example, I'm currently, why I also put healthy groups out there was because that is something that is currently frustrating me,
Okay.
because I think I've spent about, say, close to 3 to 4 weeks trying to figure out what are healthy groups and how you proceed in these abstract analyses, right? It could be something like how I started was, uh, first I needed to understand if there is any differentiation between, say, bad groups, good groups, or great groups. Is there even a difference, or are all groups the same? That is the first level analysis that you need to make. So I started with a k-means clustering, just broke them down into different clusters of groups. I found that some groups are, and I'm sure you guys must have experienced this yourself, there are some groups on Facebook and LinkedIn that are just one member groups, right? The owner has created them for a certain purpose, but they invited 10 people, nobody joined. So it just remains very small and dies out eventually. The other kind of group is, say, a very, very large group where people are active, people are just putting random stuff and nobody knows who started it and why it was started. Um, the third kind is somewhere in the middle, not too big, not too large. Could be a alumni group, could be a topic based community, could be a lot of these things. And talking about certain aspects that actually make sense over a period of time. So I want to find those groups and I want to analyze how they are doing as compared to the other ones. So for an example, if I have 500 members in my, say, good group, how many of them are contributing to the group on a daily basis? Are there 5 of them, 10 of them, 20 of them? Is that 3% of the group, 4% of the group? If I compare that with large groups will have probably only 0.5% of a contributor, 1% contributor. So I will use that to now define a healthy group, right? I will say groups that have at least 4% of contributors on a week-on-week basis. That is my first filter. Then I find more filters like this. Are my members different? Are they from alumni communities? Are they from topic communities? So on and so forth. So finally, I come to a definition that will be something like healthy groups have 4% week on week contributors from their group size. They are usually alumni based groups with this much probability, and they post this much in a week at least, and their admins do this in a week, and they have members from these 3 domains. So now this becomes my definition, and everything that clears this definition becomes a healthy group, something like that.
Okay.
Does that make sense? Or?
Yeah, it means it answers my question, but from that I have another question. Like,
Yeah.
data scientist role is mainly means taking the data, means on depending upon the business problem, taking the data from various departments and making some analysis on that data, which will probably help the management or other persons to make the decision better about that product or software. Is that correct?
Very true. Yeah.
Okay. So after we give some analysis, we don't have any role as such in making the decision itself, right?
Right.
Okay, got that. Fine.
So I wouldn't say no role, because how LinkedIn does it is, and this is very contextual from organization to organization. So yes, you are presenting your facts, but you could also be a recommender. So how LinkedIn does it is data scientists recommend future decisions, which is why a lot of data, and mostly every data scientist in LinkedIn is usually a business facing person who is now technically very adept. And we give recommendations to the product that these are some things that you should be doing, which is why business understanding for data scientists is a very crucial aspect of their journey, because you have to be giving the recommendations. Now, at the end of it, the product may or may not choose to take all of your recommendations, but they will definitely appreciate that you have a viewpoint on things, because your viewpoint is the most important viewpoint because you've seen all of the data.
Okay.
Yeah.
Okay. That answers pretty well. Thank you.
Awesome. Thank you. Are there any more questions on this before I move forward?
So is this happened to you sometime, like you have derived some decisions, you have came to some decisions, and means that is not what they have wanted or they want to hear. So that will be the frustrating moment, I know, but
Yeah.
still.
I think it wasn't as frustrating, but it is definitely, it's happened to me very recently as well. It's not happened as much at LinkedIn, but it's happened to me in, say, the startup I was with, or even at Udacity, right? Because business leaders sometimes, the thing with data scientists is you're sometimes working with very senior business leaders. So, for example, you're working with the managing director of India at Udacity, and Udacity has a certain way of doing things, and they believe that this is the right way to go because they've experienced the industry a lot more. So even if your data says something else, they're not ready to do that for the business because that may involve a big business call, a lot of money to be put into the business, a lot of things, right? So I wouldn't say it is frustrating, because you have to understand that what you are presenting is a data backed view of it. Now, data scientists sometimes don't have the entire context of the business. Maybe what I'm recommending to them costs them a lot of money and they don't have money that time. So just because they didn't take my recommendation, I'm not supposed to feel bad about that, because I have context only of my work. I don't have context of their work, their situation, their surroundings. So I'm also, at the end of the day, just giving them a viewpoint, another lens to say consider before they make their final decision. So whether or not they make that decision rests with them, because they usually have more knowledge from all of the other spheres as well. But I am just giving them one perspective, which is my own.
Okay, fine. And means at what stages of the product or project data scientist role gets involved?
From the start to the end. So with LinkedIn groups, we first had to give the new groups team a lay of the land, right? Say the new project is set up, the product head comes in, and there are 7-8 members, right? Like I mentioned, a lot of people come in to see how do I market groups, how do I design groups, what features do I make as an engineer, uh, what businesses or what markets should I sell them to, what kind of design do I put in this. So when the first discussion is happening, the first thing that the entire team needs to know is, where is groups right now, what is happening with our product right now, or what is happening with our market right now. Are we already in a particular market? What kind of users do we tend to? So on and so forth. So it starts from the very beginning, where you set the tone of, this is where we are, this is where we need to be, and this is how we'll get there. That is your first role as a data scientist. It goes on till the end, when you're monitoring the experiments that are running based on the features that you suggested should be built. So it is almost from the start to the end, everywhere.
Okay, thank you.
Yep.
I think that's it, I think.
Awesome. Thank you. So I'll move forward. A couple of behavioral and technical traits to address in, say, a data science role. And I think this remains a very, I think there's a very important slide of sorts, because there are about 5 pointers that I've put down here. The first, and I'll just walk you through the 5 pointers, and I'll give you the one pointer that I feel is very, very important is that the first one, of course, you have to be very good at problem solving. And by problem solving, I meant that if I give you something like a redefine healthy groups or even define healthy groups, you'll have to think from so many domains that you'll be confused. That what do I do? How do I define healthy groups? How do I approach this analysis? That is the core skill, and not say if I give you 10 steps to execute those 10 steps is easy. But to come up with those 10 steps is difficult. Technical expertise is great to have because I think I'm not a fan of the entire Python versus R versus Julia debate, or God knows how many other languages that you put in that debate. But I personally think it doesn't matter what language you code in, just that you code in one language and you code well in it. So my personal strength is with R. I'm not very, say, savvy with Python or very hands-on with Python, but I do get around it and I use it where I have to. But my first language of sorts is R. My second language is Julia, and my third is Python. And of course, Pig, Hive, and all of those database languages is something that you need to know at the back as well. But from a pure play code perspective, just have one language that you're good at, and that's what matters. But you need to be hands-on with databases, as I mentioned, right? Because you have to sometimes query Hive databases, Kafka databases. You have to probably, a lot of times you will query SQL databases. So I think across the board with databases, if you have to learn one skill, that should be SQL, and there's no two ways around that skill right now. Open to failure and open to feedback, because people will give you a lot of feedback on how you should structure your analyses, because data science is at the end of the day a science, right? It's an art, which means art can have so many viewpoints that you have to sometimes be open to feedback. Now, whether you act on that feedback or not is entirely sometimes your decision to make, sometimes not, but sometimes is. And you can choose to make that decision for yourself, which is where you have to be open to listening to other people's viewpoints. Open to failure is very necessary, because sometimes you'll do so many iterations that lead to nothing. You have to be very good at communication. You have to be very good at presenting your data, because a lot of times you might be getting the best data from the best places, but if you can't put that through to the business, and by communication, I don't mean speak one language very good. I probably just mean the 5 people who are sitting in front of you need to understand what you're trying to present, and how you do it is your play. You can use a language, you can use strength of language, you can use maybe different presentation skills, you can maybe use gestures, body language. You can probably, if you have a great rapport with them, I think that could be great too. But across the board, I think communication and presentational skills are very useful. The final one, which I skipped before I moved on to this, is something I feel is one of the most important points that a data scientist usually covers, which is you are curious, and you are, I wouldn't say creativity straight up, but you are curious and creative in the way you approach your thinking. And by curious, I mean try to figure out every single angle of what you're working on. If I pick up LinkedIn groups, I want to know who joins them, why they join them, when they join them, what kind of owners exist in these groups, what kind of people come here, what kind of conversations are happening, why the groups were created, why they are shut, why they are engaged, why they are not engaged. Are they coming from a particular country, from a particular domain? How often do they span everything, right? End to end, just be very curious about everything. I think that is one of the key things that you will require, because honestly, I think curiosity can solve every other point that I've listed here on this entire screen. I think that is one of the main things that you guys can think about across the board, because it will genuinely help you in trying to figure out what problem that you need to solve, how well do you need to solve it, and what you need to do to go about it as well.
Shantanu, I'm just
Hey.
launching a poll on the learner screen.
Yeah.
It won't take more than like 15 seconds. So I'm
Awesome, cool.
guys, I'm just launching a short poll. Please take it. I would like everyone to take the poll. Thank you.
I hope I can skip the poll.
Yeah, it's only
Yeah.
for the learners. Shantanu.
Awesome.
Cool, it's done. Yeah, you can continue.
Great. So I think these are a couple of skills that I wanted to touch up on. And I think broadly, one key thing that you guys need to remember as you move forward in the field as well is, and I think this is something that I address quite sometimes and make sure to bring up almost every time that I speak to prospective data scientists, is that the field is lucrative. The field is very interesting to be in, but that also makes it very hard to be in the field because a lot of people think it's lucrative, right? And the, if you know, notwithstanding the economic conditions right now, I think one of the best things that is happening to the field right now is a lot of data is being generated that is not very close to our domain directly, because machines are not expecting humans to behave in this way randomly, right? Nobody could have anticipated what will happen with the world that has happened right now. And some people could have anticipated, but the data that we've been collected has not anticipated that. So there is one entire uptick, which we call the outliers, right? And that outlier is the entire coronavirus period at the end of it. And it just gets very tough for now machines to be able to be modeled on this data and so on and so forth. Coming from there to understanding the layoffs that have happened recently, which means that you are competing for data science roles with ex Uber data scientists, you're competing with ex Swiggy data scientists, ex Zomato, ex Airbnb. I think that gets a lot tougher for you, because if you're just entering the field, one of the core things that the field requires is experience in the field. And for a lot of people that feel that experience is not something that should be accounted for, I personally think that I would also make sure that I only hire experienced data scientists if I'm working at a large organization. And that's only because data holds a lot of power in decision making. If I am heading a product and if a data scientist recommends a certain decision to me, I will almost all the time go ahead and make that decision. And at such scale, right, at LinkedIn scale or at Facebook scale, where we have 1 billion users or 2 billion users as compared to Facebook on our platform, that one decision can impact a billion people incorrectly sometimes. And that's not something you always want with your product, which is where for someone entering the field new, I would recommend you start, and you should apply to everything that you see that fits your, that fits something that you're interested in. But make sure to apply with very curated and very, say, handcrafted reasoning to smaller and SMBs as well, because I think you learn a great deal with data science if you work with, say, startups or SMBs or even mid-scale enterprises, because sometimes they are very open to hiring data scientists that are very new to the field. And I think that is a very easy and progressive way to go forward. I won't say easy, but a progressive way to enter the industry at large. And you'll find that a lot of large organizations, right? At least I know about LinkedIn, Facebook, Microsoft, Google, and all of these organizations, that data science roles are not usually filled in by freshers. Because at this scale, everybody wants to make sure that someone's done this work before they start impacting billions of people out there. So I think that's one thing, that you could either start with smaller enterprises to begin with, or ancillary roles, right? One of the key roles that you can start with before you enter the data science field, of course, is, say, a business analyst role or a business analytics role, a data analyst role. And these will eventually lead you to data science. And that may eventually, sometimes data scientists do model building, sometimes they don't. If they do model building, then you're in the data science role that you want to be in. Otherwise, you can also join, say, a machine learning engineer role. And whereas the word data scientist is used a lot, I just want to clarify across the board that there are multiple roles of what you call a data scientist, right? And this is, say, a data analyst role where you're pulling in data to show to the business. There is a core data science role where you're also making product recommendations. There is a machine learning engineer role where you're probably only building machine learning models, no product recommendations. And there's a new role that recently came up. I'm forgetting the name of it, but it's mostly like a bridge between product and engineering. It's called the translator, I believe, the analytics translator, which understands the data that the data scientist is giving them, but explains it to product better. So I think that's just one more role there. But if you're more interested into product recommendations and giving product the right way to go about it, telling business leaders what to do, then the data scientist role is what you need. If you're better off with giving the data to someone and letting them make their decisions, try looking for data analyst roles or supporting roles of that sort. If you're only interested in building hardcore machine learning models, then check out machine learning engineer roles. And I think these are a couple of things you could keep in mind as you keep moving forward as well. Of course, one thing that I also wanted to touch up on is that don't worry about the kind of code you write right now, because as I mentioned, be curious, be problem solvers before you be data scientists. And I think that is one of the best things that you can start with and learn from right now. Are there any questions? I'd love to take some questions at the end. Yeah. So across the board, I think this does come to the end of the session. I wanted to make sure that I address anything that you guys have off the top of your head, because some of you are from very different domains. Some of you are, say, already in the field in some shape or form, and some of you are just learning, have a lot of experience. So across the board, if you have absolutely any questions on the field of data science, how to get in, how to get out, if to get out, and so on and so forth. So happy to address anything that you guys have off the top of your head.
Shantanu, I have a question.
Hey Dave, is that you?
Yeah.
Yep.
So how different is a data scientist role from machine learning and data engineer?
A very good question that you asked, because I would say it is quite different somewhere and it is not quite different as well. So I'll explain the pipeline to you first before I answer the question. Since you're very experienced, I'm sure you're, since you asked the question as well, it starts with software engineering, right? It starts with the Kafka events, the Hive events, like the, say, Apache events that are being fired somewhere. Those events, when they are being fired, are being stored into, say, Amazon S3 buckets or somewhere, or even in Hive unstructured tables. Those tables then need to be used to either make them structured data, unstructured data, NoSQL or SQL. Then you use SQL to query that data, bring it to your system. Once you bring it to that system, you analyze that data, you bring it into reports, you send those reports out to someone so that they can explain it to someone else. And once that explanation has happened, maybe a decision is made that comes to you. Then there is a model creation phase where you might be using it for predictive analysis, or maybe you're just exploring data. It could be two different things. If you're building models, you go back and forth with engineering, try to improve your accuracy. Business goes out of the picture there then. I think these are a couple of stages in a data science lifecycle. The roles are different across the pipeline. The data scientist role, as you mentioned, is what LinkedIn, at least LinkedIn, calls the unicorn data scientist, wherein a data scientist does everything that I just mentioned to you right now. But you don't have to worry, because this is something that is very personal only to LinkedIn, or maybe Facebook, or say a Google. Because a data scientist, it's called the unicorn data scientist, where you're across the board doing almost everything that a data scientist could do in this pipeline. But at LinkedIn, we also specialize mostly in the business product recommendations, because we're more aligned to the business than we are to engineering as much. But in the roles differences, a data engineer would be the one that handles all of the stuff that comes from the Kafka to the Hive tables to the SQL to giving the data to the right person. That is what a data engineer would do. Analyzing the data to giving the reports is what a data scientist would normally do. From the reports to say business decisions, maybe business analysts would be experts on that. From building machine learning models to fine tuning your data, maybe machine learning engineers are good for that. So these are 4 roles that come out of the same pipeline. I think that's where you need to pick what you're more comfortable with and just align yourself in that space a lot better. I hope that answers the question that you.
Yeah, Shantanu. So one more question.
Yeah.
How about these cloud technologies? I mean, should we learn any cloud technologies, or how important?
So by cloud technologies, is there a specific one that you're referring to?
I mean, like this AWS things, right? AWS things and Microsoft Azure. So should we learn any kind of technology related to cloud?
If you are inclined to data engineering, you will eventually have to. But if you're not, then I don't think it's it's good to know at the back. If you ever need to use it, if it comes up, then just learn at that time. But it's not something that you need to actively learn if you're not getting into data engineering as much. But mostly like learn on the go. It's good to know, it's good to have on the back of your head, but it's not something you need to spend all of your time trying to figure out if you're not going into data engineering as much.
Okay, thank you.
Yeah. Dhruv, I believe you had a question as well.
Yeah, so I just wanted to understand what is the scope of, say, data science in a field like sports in India?
Data science in sports has a lot of scope. Data science in sports in India sounds a little. I'm sure that you're asking football particularly.
Not necessarily. Just
Cricket.
just a broad sort of overview of where do you see, like, say, is it growing, or do you really see it be a field which will require, like, I know across the world, like teams and all, they do use data scientists and data analysts to make some decisions regarding, say, players who they might draft or
right.
they want to sell. I mean, just looking at that and keeping India in mind, do you see a growth of demand as to, like, do you see that teams will require data scientists, or do they even welcome the idea of using data? And like, so just want to get an overview, because I thought you might have a better like understanding and knowledge since you're already in the industry for a while.
So of course, I think very good question, and thanks a lot for that. I hope I have a better perspective on this. Since I think the sports industry is something I have an opinion on. How informed or not informed, I think you'd be the best judge of that as well, since I'm also learning a lot of things here. But I believe that the sports industry, and why I zeroed down on football particularly, is that the sports industry at large is using data science, but some sports are using it a lot more than the others. So I believe you were referring to the Moneyball movie as well. I'm not sure if you were.
Yeah, but, I've seen that as well. So they definitely had like that entire algorithm which they referred to.
So across the board, I think when you look at baseball, when you compare that to football, or when you compare it to cricket, some sports are using it a lot more than other sports. Why I picked out football particularly is, of course, not because I have personal affinity to the sport, but also because it is using the maximum data science amongst all other sports. Because if you look at Europe, right, football is Manchester United particularly has a very robust data science team. And you'd be surprised to hear that, because not just in terms of what players to pick for my teams, like in IPL as well, right? A lot of cricketers have certain run rates, certain ways of delivering, certain behavioral aspects on the field as well. A lot of this is used to make data-driven decisions, but more in terms of, and I may have a global outlook, but I find that data science in sports in India is still very bleak. But globally, I think a great way is that football is doing a lot, not just in terms of what players to pick out, because that usually And I like to divide this in two ways, right? Because I feel that some aspects of some sports and even some industries are better suited to experts who have a personal understanding of the field. So I'll give you an example. I could probably predict with 99% accuracy right now whether a person will have a certain form of cancer or not in their body using machine learning. But should
Okay.
I be doing that or should I not be doing that is something that is very specific to the human element of that field. That same way, if I compare it to sports scouts, football coaches, I think they have a very particular experience. 20 years into that industry, 15 years, they've seen the growth, the rise and fall of athletes. And I
Yeah.
think even though data can predict to a huge extent a lot of this, data also might have some biases that you probably will never know till that player turns out to be bad.
Mm-hmm.
So not just in terms of analyzing what players to bring in and bring out, whereas a lot of teams are now doing some form of data science there, but data science is now heavily used in how to make players better in their own game as well, right?
Okay.
So maybe helping them take better free kicks, maybe helping
Mm-hmm.
them perform better on the pitch,
Yeah.
right? Maybe
Yeah.
bowl better, maybe bat better, how to optimize their stamina better. Are they
Mm-hmm.
running for, say, are they running in football or cricket unnecessarily where they're not supposed to run? How can we limit that? So
Okay.
optimizing a player's throughput as well is something that data science teams, especially at Manchester United, I'm aware, are already doing.
Okay.
Uh, so both in terms of throughput optimization and bringing in players, I think it's being used in both spaces. And sports is an industry where data science will explode eventually because we're slowly moving towards fan-based experiences, which are going to be more remote as compared to in-stadium experiences now because of the pandemic. And I
Mm-hmm.
think it's bound to grow. I'm not sure how much in India because we don't have the supporting ancillary infrastructure that
Yeah.
is required. Because if you compare an Old Trafford cricket ground versus Old Trafford football ground versus the Wembley football ground,
Mm-hmm.
Wembley cricket compared to say a Brabourne or a Wankhede in Mumbai,
Yeah.
we don't have that kind of camera equipment, that kind of infrastructure that those stadiums have. They have views on every single element in
Yeah.
both of those fields, and we don't probably do that. So
Mm-hmm.
till the time we have right data, I think data science is just a dream for us in that industry in India right now.
Okay. Okay. Thank you.
Yep, I hope that answers your question,
Yeah. Yeah.
Nicholas.
Definitely gave me a better perspective.
Awesome. I hope. Thank you.
Yep.
I have a question. In what different kinds of thing means data comes means in Excel or in databases, or there is something else as well?
So
Wait,
very glad that you asked that question.
yeah.
Is there more to that
No,
question? Sorry.
I just came. This just came in mind just because you said like there are no good equipments on
Yeah.
Wankhede to capture the data. So that's
Awesome. So, of course, I mean, I'm sure there are some equipment that Wankhede does well because
not like
uh,
that, but just
yeah, awesome. Because I think I've studied right beside Wankhede at Jai Hind particularly as well. So, I've gone to the stadium multiple times. So, nothing
okay.
against the stadium.
No.
Um, but of course, I think very good question that you asked because sometimes we have a personal affinity to Excel and tables, right, and data of that sort. But data comes in almost every format that you can think of, and I'll give you very wide-ranging examples, right? So one of my friends has a self-driving car company that he owns in California, and they have data based on RFID sensors on the roads, and that are transmitting even temperature data, right? So, for example, if you are the Indian Meteorological Department or maybe even NASA or something like that, you have these sensors in Antarctica that are sending you temperature data almost every 10 minutes. Data can come in from RFID sensors like that. Data can come in from self-driving car movement. Data can come in from video. Data can come in from audio, from text, from uh, everything across the board, right? And different ways to be able to pull that data eventually, because sometimes you have structured data in tables, sometimes you have audio data, right? So audio video data, how do you break that down? You break that down into certain frames, you break that down into features like amplitude, and I think 11th grade physics teaches us a lot of this, which is amplitude, say pitch, and a lot of that, the features that are in every audio clip. You can translate that to video, maybe what kind of features are in videos, right? Say, and I've personally not, I'm an expert in, I'm actually an expert at nothing, but I would find myself more inclined to solve better problems in the natural language and text standpoint. So I'm not very sure what kind of features you can draw from video, but you can draw movements, you can draw, say, what kind of objects are in your screen at one point in time. If there's something coming up from the front, you need to dodge it as a self-driving car. In the text-based data, I know for sure that things like how many pronouns, how many nouns, verbs were used, what kind of words were used with what kind of words, how often are people writing longer sentences. There is also Fletcher-Kincaid score that we compute in NLP, which is basically how complex are the words that you're speaking or you're using, right? Are they comfortable enough to be understood by a 5th grader, 10th grader, college education, undergrad education, doctoral level education? So these are some features that you can draw out from all of this kind of data, and it comes in many shapes and forms. But the broad way you could think about it is structured data and unstructured data. I think that's the broad distinction you could make there.
Okay, thank you so much.
Yeah, thank you. Are there any other questions? I'd love to, since I think we do have a couple more minutes to the session. So happy to take up any other questions that you guys have off the top of your head as well.
So I have one. Is what is the main distinct means data science do have to interact with or do have to do AI as well sometimes?
Yes and no. We do AI at LinkedIn in the data science team as much as we need it to help the business and product align their strategy. But for the algorithms that LinkedIn actually uses on their platform, the recommendation algorithms, the people you may know, all of that, there's a particular AI team that does that, because I think very different skill sets required for both of these. You can't really merge them. Um, it's more of a, data science would be like an umbrella function that does a little bit of AI, that does a little bit of engineering, that does a little bit of everything. But we do have a particular AI function that handles AI. So it depends on the scale of the organization. If it's a smaller organization, you may actually be doing AI. I've done AI as a data scientist particularly, but it's not something at a larger scale that you will be doing.
Yeah, but AI will be more of a like after taking a decision on
Yep.
that data. So
Yep.
it will
Yep.
be in somewhere in the implementation cycle.
Right, exactly. Which is why depends on the scale of the organization you're in, because if you're in a smaller one, you are probably in that same cycle when the decision is also made. So you are also doing that, you are also doing this. So I think you're
Okay.
across the board. That's the
Okay. Got it.
yeah. So any other questions I'd love to take up? In fact, just before I forget, if you guys have any questions outside of uh, the session as well, I'm happy to, if you get stuck on almost anything that you guys have, I'll just share my LinkedIn profile with you guys as well. So happy to take up any questions that you guys have outside of the current session as well. If you, I mean, because sometimes it's very hard to think of questions in the moment. So if the session ends maybe 3-4 days down the line, if you have a question that you think of off the top of your head, I think you should definitely make sure to drop me a message as well, and I'll be happy to answer it.
Thanks, Shantanu. Guys, if you have any more questions, feel free to ask. Otherwise, I think we are good to end the session. Any more questions, guys? And I've also shared a short feedback form with you at least a couple of times. Please don't forget to fill it. And I hope this session was useful to you and it will help you. We'll keep such sessions regularly. So thanks for joining. Thanks for your participation. Glad to see everyone joining the session on time. Thanks, Shantanu. Thanks for the wonderful session.
Awesome. Thank you so much, Vijay. And thanks a lot, everyone. If there's anything apart from questions as well, if you want to share any feedback on how I could particularly focus on some topics better and something of that sort, please feel free to drop me a line on LinkedIn or on email or anything that you guys find comfortable.
Yeah.
Awesome. Thank you.
Thank you
Thanks
so
for the
much.
session,
Thanks,
Shantanu.
guys. Enjoy your
Thank
Sunday. Stay safe. Okay, then I think we are good to end the session now. Please fill the feedback
Awesome.
form, please. Thanks, Shantanu. Bye-bye. Thanks, guys.
Thank you. Bye-bye.